Hey, all, today we're going to continue talking about random variables. And this time we're going to talk about what happens if we manipulate those random variables by either adding constants, multiplying by constants, or even combining random variables. So in the last lesson, we talked about finding the expected value of a random variable. Expected value looked like that. And that this is a capital letter X. And that capital letter X just represents the random variable. So in this case, we were talking about a discount at a restaurant on Valentine's Day, and we found the expected value to be $5.83. There's a little recap here, and we found the standard deviation of that random variable to be $8.62. And it's important to remember that standard deviation and variance kind of work hand in hand. The variance is the square root of standard deviation, and therefore, I'm sorry, the standard deviation is the square root of the variance, and therefore the variance is the standard deviation squared. So it's good to know those things. So our variance was 74.3044. And so in this example, there was a $5 coupon that you could also bring in. So there was the potential of getting the discount when you draw an ace of hearts or an ace of diamonds. And now we have a $5 discount. So this $5 discount, you don't have to do any drawing the correct ace. You just get the discount if you have the coupon. So this is a constant discount. So we are adding a constant to our random variable. And so in order to do that, if we want to add or subtract a constant to our random variable, we are just going to take our expected value and then add or subtract that constant. So here our expected value was $5.83. And so we're going to add to that $5 for bringing in a coupon. And so our expected discount, if we have this coupon, is $10.83. We can calculate the standard deviation and the variance as well. And I think you'll like this calculation because when we add or subtract a constant to our random variable, the variance is just going to stay the same. And therefore, that means the standard deviation is going to stay the same. So the only thing that's going to change when we add or subtract a constant is the expected value, which remember is like a mean or an average. And so if we're just adding, we're not really changing how spread out the information is. And so that's why the variance and the standard deviation change the same. We're not changing how spread out this model or probability distribution is. We could also multiply by a constant. So if we multiply our random variable by some constant a, it's just the same as multiplying our expected value by that same constant. So in this case, we are going to get double the discount if we have two couples. Is that what it is? So if you go on a double date here on Valentine's Day, and you all pay on one check, you can get double the discount if you draw the ace of hearts or the ace of diamonds. And so doubling means multiplying by 2. So in this case, we would just take our original $5.83 and multiply that by 2. And so we would get an expected discount of $11.66 for a double date. So on average, two couples coming in and sharing a check will expect to save $11.66. And to find the variance, we are going to square that number we're multiplying by and then multiply it by the variance. So our original variance was 74 point, we'll call it 3. And so we're going to take our 2 because we're doubling and multiply it by 74.3. 2 squared is 4. So our variance is 297.2. And then the standard deviation is probably what we are more interested in. So we can square root that variance. And find out our standard deviation here is 17.24, we'll call it. It's very important to note that as we go through this, we want to find variance before we find standard deviation. Because of the squaring and square rooting, it's important to find the variance before we find the standard deviation. And so, and standard deviation is the thing we talk about the most, and this is in dollars. So if we have two couples getting the same bill together, they can expect to save $11.66, give or take $17.24. Sometimes more, sometimes less. And sometimes we want to actually combine two different random variables. So far we've added a constant to the random variable. And now, and also we've multiplied by a constant there. We doubled up and multiplied by 2. And so now we actually want to add 2 random variables. So here we have the double date, but they want to get separate checks. You know, they don't want to worry about splitting up the bill. They'll just each pay for their own meals. And so we can find out what would happen if we have one couple, their random variable is X, and then we add to it the other couple, the random variable, we'll call it Y. So X is couple 1, Y is couple 2. In order to find the expected discount, we can just add the 2 expected discounts together. So in this case, couple 1 can expect to save $8.62. Oh, that's my standard deviation. Sorry. I knew that was wrong. And couple 2 can also expect to save $5.83. And so if we want to find the expected discount for them together when they pay separately, so we're not multiplying now, we're just adding them together. $11.66. Of course, you know that adding two things together is the same as multiplying that thing by 2. And so we get the same expected value, the same average discount, whether we double it or we add them together. But here's what's going to change when we talk about how much our discounts are going to vary. We'll get more into why later on as we talk about probability, but in order to calculate the variance when we add 2 random variables together, those variables must be independent of each other. That means that one happening is not going to affect the probability of the other one happening. So we can add the variances together. And this is when it becomes very important to find variance before standard deviation. And we could talk about that together. And so our variances were 74.3. So I'm going to add them together and get 148.6. And then to get my standard deviation, I will square root that. And I know I'm going fast, so make sure that you're pausing and rewinding when you need to, or you're popping your hand up and asking me a question for help. So we're going to get a standard deviation here of 12.19. So even though the couples who dine together, when they get the same check, they save on average the same amount of money as when they split the check and pay for their own. But the variance in the standard deviation when they share a bill is larger than when they get their own bill. So the advantage here is there's less deviation in the discount when you pay your own bill. And actually, you might consider that an advantage when you don't pay your own bill because there's a chance of getting a bigger discount. There's a bigger variation, so that means you could get a bigger discount. Subtracting random variables is going to be similar to adding. And so I'm not going to actually do this problem, but I'm just going to point out that when we subtract two random variables, we do the same thing we would do when we add two random variables. We simply just subtract them. The only difference here is then when we calculate a variance for the difference between two random variables, you're not going to subtract the variances, you are going to add them still. If you want to, you can do this problem on your own, or you can ask me, we could do it together in class. But for time's sake, I just wanted to point it out. The only difference between subtracting two random variables and adding two random variables is that you subtract to get the expected values, but the variances are still being added together. And of course, these variables need to be independent of each other for us to do this piece. And we can talk about that more when we get into probability and independent variables. And then the last thing would be like, what happens if we have 40 couples that come out for dinner this night and we want to know the expected discount for the entire evening. And so this is really just adding 40 different random variables. I'll call the first one X1, and then we would add to it X2 for the second couple, and then the third couple, and then I would keep adding until I got to the 40th couple. And so we can calculate this expected value for 40 couples the same way we would calculate it for two couples. We would just add our expected values for each couple all the way up until the 40th couple. So we're really just adding $5.83 40 times. And so, adding $5.83 40 times is the same as multiplying by 40. And so our expected discount for the 40 couples that have come in this evening is $233.20. The same thing is true for the variances, and you can do that on your own. We could do that together if you really want to. We would just add up 74.3 40 times, and that would give us our variance. So our variance would be we would just add our variances, and this could get very long. Oops, I'm getting a little sloppy here. We would just add that 74.3 40 times, and then we would square root our final result to get the standard deviation here of the 40 couples coming in. So if you want to, you can do that on your own. You can ask me in class, we could do that together. But in the interest of saving you a little time here, we're around 15 minutes. So I want to make sure that you have a chance to finish the lesson and answer the questions. Make sure you answer the questions at the end here. If you have any questions about anything I talked about in this lesson or the questions that you're working on, as always, ask, and I'm glad to work with you and help you. Take your time on these, and good luck.